Hey guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 16 on my linked list series. So far I covered 15 lectures and I highly recommend you to please start from lecture 1 until whatever I'm going to post in future. And I believe at the end of this series you will be in a position to solve any linked list problem. And without further delay, let's get into today's lecture. Today we are going to solve one more lead code medium problem. The problem number is 1472, design a browser history. If you people recall, in lecture 1 I explained what are the real-time examples of linked list. So one of the real-time example is our browser history. So let's assume we are in a current page. Okay, so we can go forward and we can go backward. So in this problem, we need to implement that kind of facility where you are always in the current URL. So you can go forward, you can go backward depending upon how many pages you visited. Okay. Without further delay, let's get into diagram for a better understanding. If you carefully observe this problem, let's assume so I have a browser. So my home page is something called leetcode.com. And from there I visited from google.com. From there I visited facebook.com. From there I visited linkedin.com. From there I visited youtube.com. And if you carefully observe, so if I'm at this position, so I keep on visiting different sites. So when I'm here, so I cannot go forward, right? But I can go backward. Like if I click on the back button in the browser history, so I can go to the LinkedIn. And if I click on again back, I can go to the Facebook. And if I click on again back, I can go to Google. And if I click on again back, I will go to the home page. And from here, if I click on forward, since I already visited Google, so it will take me to the Google. So from there, I can go to the Facebook. From there, I can go to the LinkedIn. From there, I can go to the YouTube. So these are the basic functionalities of any browser, right? So we have that back button, we have that forward button. So in this problem, we need to design a kind of system where it needs to perform these kind of operations. Now tell me like what are the first thought which is coming into your mind looking into the problem. So if you carefully observe, if you are at this URL, assume this is a current URL, you have two possibilities. You may go to backward, you may go to forward, right? That means you need to have the references to the previous URL and you need to have the references to the next URL. Clearly, we can observe this is a variant of doubly linked list and it is going to hold URL and this is the previous pointer and this is the next pointer. So previous pointer is going to hold the address of previous URL. I'm denoting URL with U and again this is previous and this previous next is going to be your current and as usual forward also URL and its previous is going to be current and its next is going to be null if there are only three URLs. Okay, so this is a kind of problem where we need to leverage the doubly linked list concept. So I will jump back to the coding part and we will start writing there. Now I am here. In this problem, actually, we need to implement the four methods. So one is the constructor, not a method, and then we need to write a logic for these three. One is visit. I will go by step. So browser history of string homepage. So it initializes the object of the homepage of the browser. So as I said, like if I start from leadcode.com, so my homepage is going to be leadcode. So from there only I can go forward. And visit is nothing but like the page which are visits, okay, and it's clear all the forward history. That means like if you are at Google, so that is going to be your current URL. So there are no forward URLs, okay. And the back is nothing but you need to come to the X steps back, and if your X is greater than your steps is greater than X, then you will return X. Otherwise, you need to return the last one. And likewise the forward also. Let's try to implement this logic. So first what I'm going to do here is I'm going to create a class called DLL node, which is going to hold the required properties for my doubly linked list. First is here we can see we need a kind of facility, right? So where you need to store this URL. This URL is nothing but string, and this previous pointer is going to be DLL node, and its next also going to be DLL node. So let's prepare our structure of the class. URL and then DLL node is equals to prev. Let me minimize it. Prev node, DLL node of next node. Okay, I'm going to have a constructor with only one parameter, that is nothing but string URL. This dot URL is equals to URL. That's it. This is a simple structure of the class. Then I'm going to hold a pointer called cur node. Okay, so which initially points to the null because we do not have any nodes in our list. And this is going to help us a lot. Okay, let's try to understand this. So the browser code is going to, I mean, the driver code is going to call something like this. So browser history obj is equals to new browser history of home page. So whenever we receive this home page, that is going to be our first node in the list, right? So for that, just do something called DLL node. First node is equal to new DLL node of home page, whatever we received. And since this is the first node, then my current node is going to point to the first node only. First node. Yeah, we are pretty much done with the first uh, implementation. Now visit. So what these guys are saying, so we are going to have a string as a parameter, and we need to make this current node, uh, I mean the URL which passed to us needs to be our current page, right? So then its next are going to be null. Let's try to see how we can. First we need to have a node, right? So DLL node is equal to new DLL node of URL. So this is done. And you can clearly see here. So this needs to point to the current node. Sorry, here spelling mistake, current node. Right. So what I'm going to do here is, so node dot prev node is going to be your current node, right? Because we already have a node in the list. So this is a new node which we are creating. So its previous is going to be the node which we created. And we made this connection. Then node dot next is anyhow this is going to be null. We don't need to worry. And then we need to make this as a current node. So that means current node is equal to current node dot next. And by the way, we need to make one more connection like kernode dot next is node. That's it. So what I'm doing here is I just created a node simply first. Assume this is with something called YouTube. Okay. So this is a pure node. Initially its previous is null and its next is null. What I'm doing here is, so after creating the node, I'm saying node.prevNode is equals to kernode. That means my previous, so as I said, we already have some home page, right? So that is nothing but some lead code. Okay, initially its next is null. So what I'm saying, this node dot previous is equals to kernode. That means this link is formed. Now what I'm doing, car node dot next is this. That means, and my car node is here, right? So car node dot next is nothing but this. So there is a link formed, both the previous and next pointers connected, and this next is anyhow going to be null, and its previous is anyhow going to be null. We no need to worry. So since we made this connection, then we are need to change our kernel to point to the newly created one, because this is the page where we are currently, right? That's all for this method. Now let's see this one. So we need to go step backs. That means, let me show you the example. And for sake of easy, so I'm using something shortcuts: G for Google, F for Facebook, Y for YouTube, L for LinkedIn, again L for lead code, and its next is null. And in the back, okay, so back method, we are going to receive some integer. So let's assume like we received something called 2, and assume our current is this. I mean, we are in lead code page. What we need to do? We need to go 2 steps back. That means our curve should point to this. I mean, 1 step went back, and then our curve is going to be here. So YouTube. So 2 steps we went back. That is all about the back functionality. Forward is also same. So if we have something called Google, Facebook, YouTube, LinkedIn, lead code, and next, and assume I am at this position. So I need to go forward 1 step, I mean to say. That means I need to go here, and my curve needs to be here. So here is one corner case. So what if your curve node is here, okay, and they give uh, back as 7. What you are going to do? So you are going to be here, you are going to be here, you are going to be here, you are going to be here. That means you went only 4 steps back, and you don't have other nodes to go back. So you need to return the this one only. Okay. And the same logic applies for the forward also. Let me go back to the coding part and here. So what we need to do? I'm going to do for int I equal to 0, I less than steps, I plus plus. Till this condition satisfies, what I'm going to do? Since I need to go backward, right? So I need to check my cur.prev should not be null, right? If my cur.node.prev, is it prev or prev node? Yeah, it's prev node. This is also next node. Here next node, here next node. Yeah, now here is prev node. So if my kernode.prev, I mean kernode.prev node not equal to null, till this condition satisfies, I need to do what? Kernode is equals to kernode.prev. That means I'm going back. Okay, kernode.prev node. So once this condition fails, okay, this complete loop will come out. So at the time, just return wherever you are, like kernode.url. That's it. So I'm just copy pasting the same logic here, because just we need to change the pointer here. So instead of prev node, it is going to be next node. That's all. So basically what we are doing here is, so wherever we are, current node, so we are going n steps forward direction. That means next node. And here we are going to the backward direction. That means prev node. So at the end, wherever we are going to return that kernel node URL. That's all for this problem. Let's give a run. Yeah, it got run. Let's submit. Yeah, it got submitted successfully. So that's all for this problem. So I hope like you learned something new today. So this is one of the real-time use case of doubly linked list. So highly recommend you to please practice yourself, and you are going to be very good in solving the linked list problems. Thanks a lot. Bye bye.